Okay. So in the chat, let me know what you all think about artificial intelligence. Everybody, stay active. Again, training machines as per human requirements. AI means information from a knowledge. What about others? I want everybody to have an answer. Please understand this is not a very simple subject. Till now, you were introduced to, I believe this batch is mostly from data warehouse side. Again, if you're sit properly, if you're lying down or something, online is a very good option, but you should not abuse it. Important topic, get your things, make sure you have something to write on, take your notes, take your coffee, whatever you need. But sit up straight and in this meeting, at any point we'll ask you to share put on your video so that marks your attendance and your attention. So please, what is artificial intelligence? If you ever heard of it, never heard of it, no problem. What do you think it should do, it should not do? Okay. Okay. All those who are in the chat, please put a yes or hi or just show that you're active. Meanwhile, what is AI? How many of you think ChatGPT is AI? Yes, please put it in the chat. Abdul says yes. Max says yes. Okay. Anybody else who wants to put an input there? In a simple terms, let's just focus on AI. Right now, you try to understand it is some machines, okay? They are doing who, how, and why. These machines, what they're doing tasks that require intelligence. Any task that requires intelligence. So basically, that is AI. It started if you get into history, what you see is there was things like eight twins problem or some Turing machine. Now, what they used to do, this was some algorithms. One thing, I want to say it in the very beginning. If you understand maths, very good. Uh, if you don't understand maths, then don't get into too much detail of maths. Whatever you hear or whatever we say, we speak the same. जितना तुमको समझ आता है उतना ही तुम वहाँ पे बैठो. Otherwise, it's okay. Just come here, enjoy it, learn something about AI. It does something magical. Try to put it into technical words. That's fine. But if you understand maths or if you want to understand maths, then it's very important to know maths. And when I talk about maths, uh, let's say probability. If ever, if you could get a really good understanding of probability, you might try statistics. So we'll come back to this later. Okay. Right now, yes, AI machine. Machines are doing tasks with some intelligence. Example, chess engines or recommendation systems. Swiggy, Insta, all those delivery apps, they give you a recommendation based on your food habits or orders. Fraud detection in many banking systems. And of course, one of its application is ChatGPT. So I hope the initial question that we asked, all those who said yes, congratulations. No problem. Welcome to Global Economy. Any doubts, Julia? What is Chat's engine? Okay, I think See, it's an algorithm. It is trained to play at chess. Humans can, let's say, greatest of great human chess players can think 10 step ahead. If he plays A, I can play, or I can at least imagine. So when you put that into mathematics, you get something as probability. Then there is winning quotient and a lot of other things. Behind an engine, maybe that was a really good question. These engines previously have become today's model, come to model and sometime. Any other doubts? Others, please be active. Otherwise, no need to, yeah. You have to understand importance. You have to, you won't talk about, what homework is pending and what task is still to be done. Uh, that's up to you. One thing that I would like to mention here is people of multiple batch are present in this session. So, even if they have, you think the freshers or your newly joined batch, you think that uh, it is not that important, then ask your seniors how new this topic is for them. They are with us last maybe some are since years, some are since 6 months, some are since a month, and all of them have this opportunity. So please stay focused and ask your doubts. The class is online. You can use any tool that you have to ask doubts. If not now, we'll definitely cover it in some other session. Remember, doubt that you have, others may have the same doubt, and it might actually help everyone. So please, yeah. No doubts. Give your responses. Right. Now let's understand some concepts. When I understand you all are not basically various backgrounds, so we should have a common or general understanding, and from there we start. You might have some might be very expert in this technology and still attending this session. That's no problem. But we are doing it for the general public. So machine learning, this is the another term. ML is famous by ML, machine learning. So what is machine learning? To be active here. You know what is AI? AI means we need to do, or machines need to do tasks that are intelligent. Plus, what is machine learning? Let's say uh, everyone uses mails. So in that mails, you have this option that you can put some of your mails directly into spam folder. In this folder, and anything that is in this spam folder, you reject it. That's what automation you can say. So what we doing is whenever any mail that drops in your account or your ID, it scans and then it rejects. Okay, that's what it does. So instead of manually doing it, that's machine learning. Instead of manually doing it, you program. You know, in our previous uh, sessions, where we say that a pre-script is designed. So we have already programmed the cluster to behave a certain way, and then we start with our session. So machine, we do it on a very uh, short level, but then that's why you have transformers that train this machine learning data. And your machine learning examples, machine learning, I hope everybody understood. It's basically manual programming that learns. Every time it detects a word, it says it should go to spam. Basically, it does character matching, words matching, and all that. Where is it useful? In spam detection, your favorite Netflix recommendations. And prediction, and we'll come to prediction systems. Why and what is system with prediction system? And the other term that is very important, that is DL, that is deep learning. What is deep learning? Oh. Now, this is, understand, it is a subset of machine learning, but they do it through different architectures. I hope till now most of you are aware what is architecture and why things change when you change architectures. And since we're dealing with we'll be dealing with LLMs, you'll understand more why what is the importance of architectures in LLM. So the subset of ML based on uh, different architecture where like neural networks, uh, huge data sets. These are basically its use. It does, deep learning is also the reason why we have AI with respect to image, speech, and LLMs. What are LLMs? We'll come to that in a very short. Most of you might have heard it for the first time. You might know. So just wait for this LLM part. I hope you have understood machine learning, deep learning. One is when they learn the pattern. The second is not only learn the pattern, um, can do more deeper analytics or uh, basically different algorithms that can be used. One of them is generating a model, which we just write down here. LLM. And once you understand this, we have Gen AI. Or generative AI. This is where um, the growth is right now currently. Demand is, modern excitement is, whatever you call it. What it does, I mean, you all know, we're all aware of ChatGPT, and there is Gemini, and lots of others. Important question, what are they based on? It is LLM. And okay, let me just large. We're nothing of large language model. So yes, the next of the session will be mostly on training of this LLM. Now things will start getting very hurtful to you all. I'm really sorry about that. We already start the sessions with sorry. But till now, what we have is, before this point, whatever I have discussed, told you, asked, or whatever you've answered, make no sense to me because a lot of data about is already there on the internet. We are not going to deal with a lot of things which a lot of other institute, I don't care whichever academia it is using it. Or they're basically teaching this those things on. So we'll try to not focus on them. because that is freely available. And since you belong to global academics, you are capable of searching or finding or going through that data. And that's why we have this community. One phone call and you understand where to drive or where the market is. That's the point said. Improve your network. Everybody have heard of those theory. Uh, Tell me your other question. Tell me your five friends. How many of you have heard this? Show me the five friends or five persons around you, and then they can. How many of you heard that story of a friend? Or tell me five people that are around you, and they can tell you how successful you can. Please be active in chat. Okay, all those who think my voice is broken, first of all, check your network connectivity. If that's good, then uh, I'll I'll keep checking my connectivity. So yes, am I audible? Is the voice still breaking? It's not clear. Okay, right. So what about others? Good point to say yes, no, and then we start. See, what I want to tell you is, I hope my voice is clear. Right? Okay, Soil says, yeah, Soil, Musayef, and all of you, please let me know if such things are happening at the back. I hope my screen is visible.
No, the screen is not visible.
Okay, okay. Just give me a minute. I hope it's visible now.
No, the screen is not visible there.
So I think it should be visible, is it?
No, it's not yet visible.
I don't understand. One thing. Musif, can you stop recording?
Yeah, yeah, one second.
So what I was saying is, most of you, this will be very difficult. Very difficult at the first time. I understand. No problem. You, since you're here, it's a privilege that with all other courses, you get to join this training also. So understand, try to learn, so try to focus more on maths, more on probability, and just stick around. You'll get hang of it. And if you completely do not understand, no problem. Don't worry. At least you'll understand at some layer of AI. Okay. So one quick question: where is the trend going in AI? Before we start with the training of LLM, two things which I clearly want to mention. Where is this going? Okay. So understand one thing. Yeah, any questions? Definitely, we are going too much of into Gen AI. Okay. But that's not the complete truth. Before we dive into why LLM, why is today's topic large language module, where I've already asked you to focus on this. Yeah, language. They had some goals. They had some goals. There's models and a lot of other things other than models have some goals because this side is machine. It has its own. Here are humans, and no doubt chatbots. Boom, sudden. So the list of this, or those who use LLM or are trained on them, definitely chat boxes. Can you name some? Yes, one of them says on the chain here. Yeah, ChatGPT, Gemini, and a lot of other things. Waiting for your info. Okay, point taken. Rob. And others, I don't think so. You are so much interested. Okay, yeah. Claude, yeah, we can try put it that way. It's more than that. So before we continue, understand this. This is AI. A part of it is, or a subset of it is machine learning. A subset of that is deep learning. A subset of that is LLM. So AI, LLM, chat, Gen. I think please ignore the. Are we clear on this? What is this? It's real. It's real. Deep learning. This is what happens when you are not when you're late to the sessions. Any other questions? Yeah, perfect sleeping. Come to perfect sleep. Very important thing. I wonder nobody said anthropic. My God. Yeah. Furthermore, any questions? Right. So then you come up with questions. Let me just. Okay. Now we are trying to talk about the training. L, L, L. LLMs is considered as this. Before that, you should understand what is large language model, right? How many of you know what is large language model? The internet might be telling you something, right? There is media also nowadays. Yes, what is LLM? Before you want to train something, you can understand what it is, right? What about it? Framework to process data. Something else. What is LLM? What it does? Yes, we can do. That's why we have this online and offline experience, because when it is offline, a lot of things are very clear. But you're also on, unless you ask, "No, I cannot see you, I cannot see your faces, your expressions, or so better is you put that question in. And when we ask something, we can basically AI system that can read, understand, and respond to human language. In a way, take a good definition from wherever you've taken this. Basically, AI system. Then again, the question is it a system? Is LLM a system? Right? What they themselves call it a model. Basically, it's a model. So let's get into things. What matters to train LLMs? We should understand how it was built, what was needed to build it, what was the purpose, what it does. Uh, Not actually when you learn. I think previously in database you learn how to use Hadoop. You did not go and started creating your own. Uh, Anyways, is that clear? Right. The next thing is very important. If you're doing anything that is very important, put it aside. These are the things that will make it clear what is the need of LLM, why it was built, and what it is actually, why it is a model not system. So LLM was basically they have an architecture. I'll just why architecture? Understand the problem. Let's say you want to train. I'm not disturbed. Let's say you want to train a human is here, and you have entire internal data, entire internal data. So one query will go through the entire and produce an answer. That's what is the line, right? As a human, you just open, let's say, any generative AI, you open your ChatGPT and you start giving it a question. So basically, uh, questions and answers. This can be dealt in a very easier way. So how do you do that? And you keep your agenda general. This can humans can be uh, layered down to students, doctors, engineers, and blah blah blah. Will come of that in some time. So how do you do that? So all this is we have something called transform. Now, since we know it uses transformer at the back end, so it's very clear that is something related to neural network. We won't go into this transformer, and yeah, we'll definitely touch a lot of neural network uh, and its architecture and all of this, uh, which will be my second point, which is training. Why was it trained? It was trained, let's say, it was trained on some algorithm, just as I said previously. And those algorithms are also very a lot of textual context or academic context is around these algorithms and transforms. So basically, when it comes to this training algos and architecture, we won't be talking much on that because there's a lot of content out there, and no, and you know, uh, so basically, my way or our community way of thinking is first let's learn to use the technology. We can get into the depths and uh, a bit later. So most of them are focusing here, but to understand, even if you have this perfect architecture or this perfect algorithm, that can only be possible what data you provide to it, how you evaluate, what will you your goals. And second thing is are your systems or what systems capable of handling all this. So when I say what matters to train LLM, this fits very well. Architecture, let's say, or algorithm, I'll just stick to a model. We call it a model. This tool is a model. Yeah. Transformers, I will mind something. Now, these models might have some input. Consider this as a black box, and then it will have some output. Now, this output is considered as a variable. What's the algorithm? What they are doing is they are trying to generate text next word. How do they do it? We already discussed it. There's a lot of likeliness, a lot of probability. And for example, now before we go ahead, you understand two things from this diagram. There is an input and there is an output. Yeah, let's say this is our model. There's some input, there's some output. This output will go through another um, code algorithm or whatever you want to say. Call it softmax, another mathematical formula, whatever you want to say. Goes through that, and then it is getting it generates a lot of textual data um, while understanding that more like a question answer approach. And obviously, at this point, because this data might be very raw, because understand reading everything, then suggesting something, maybe clarity, honesty, integrity, all that comes into picture. So they have to, you know, make sure it's very appropriate and secure and not offensive. All those, and basically, again, they are mastering the English language. You know, if you want to learn mathematics or any other, let's say, transforming yourself, all this AI, I would suggest you all keep reading English, right? Because all this somewhere it is stored in English, read in English, calculated, done in English. For example, uh, calculators. Now, calculators, it's a similar thing. They might have different model, different, how the way they learn 8 plus 8, they understand characters. That this is 8, maybe by the help of the algos behind it, multiplication, addition, dot product, blah blah blah. but they understand, and that's why it is very fast. But when you use a model to scan the entire internet, um, that's when the problem will get bigger. I hope I hit some point here. Any doubts, William? You please ping in the chat. I'll be sharing and waiting for your questions. No point going ahead because I hope you have a good understanding or some understanding of why LLM, even LLM is part of AI, or is it some magical concept? Right? Put your questions there. Yes, what about others? If you're good with it, uh, let's move ahead. Yes, I know it's very surprising for few of them, but understand that's how it's never easy. You're trying to get into a technology which is the need of, I won't say hour, but minute. And then again, since understand one thing, we, or as far as I know, this community is being more uh, favoring or more in likes of operations. So all this, when at the right time, let's say Linux was introduced, at the right time Kubernetes was introduced, at the right time LLMs was introduced, and so on. So, but operations where they run on, how to manage them, uh, that is still not gone. It's still the we'll come to systems. We'll come to systems. Don't worry. I think it is the most hot topic right now to work on, talk on. But yeah, we need to develop better systems. Now, said that, that's why from operations perspective, at least try to understand this because somewhere it will help you. Said that, we are doing LLM. So now this LLM, I explained you model, and this is called pre-training. The inputs that you give goes through some pre-training, and then the output that is generated by the model gets some post-training. And after that, it is being put out there. All this is, let's say, pre or post training. Initially, you might be, or you can just Google around and come to know. Uh, a lot of pre-training was done for GPT. I use my previous example where it says, you have a web crawler that has to get all the data on the internet, and then you have to train it in a way that it answers in a language model. That language is English, because in English it's very easy to tokenize. Will come not easy. Let's say we had to start from there because that's what the language they've already built on other things. So English, they were training mostly for English point. We don't forget the language. The language here is English. They were very focus driven towards the language English. And for that, ChatGPT 3 will, a lot of stuff will happen. during that time. Post training was we had this GPT-3, and then they trained it. I told you they got some raw data or a very unfiltered data, very non-governance kind of thing that would require governance and um, all that stuff. So in the post training, we have ChatGPT as an example. Okay. Now said that this LLMs are built on language models. I previously mentioned a few things about it. Languaging is basically see, I started the session with probability. Here where it connects. Probability distribution. Uh, right now, just if you've heard this, if the math is not strong, don't worry. Just hear the words, practice, keep hearing it. Uh, it will make sense. First lecture, I don't expect any of you to make this sense. This should be all of our bouncers, or maybe your heads are boiling. Uh, we'll do question and a lot of question answers so that we know what point you have understood. So LLMs are built on language modeling. They are nothing but probability distribution. Now, obviously, probability has some sample space. We can also call it as sequence. Here, they use sequence of tokens. Let's say you have 10 words. So P will always stand for probability in my entire section. Okay. So whenever I mention P, it's always probability. So probability of x1, which is the 0 till x of plus, where L stands for plus. I know you don't have to remember this. What you remember is language modeling is probability distribution. Later on, we'll talk about tokens and words because since here it is language, there is this instead of tokens, you can also call it words. But that's not how tokenization works. So we'll come to that later. That is completely different concept. Okay, these tokens are different. Now, before I start with some of examples of language modeling, how this distribution is done, uh, please ask your questions if you have any doubt. It's an online session, open session. Does LLM predict the answer is definitely yes. Uh, that's what I don't say. Language model. Basically, what is language model? Everything is based on weights. Uh, Now we'll be introduced to a concept. What is ChatGPT? What is Gemini? What is all these chatbots? They basically are generative models. So here we can point a good question again. Uh, Language modeling is basically also called as generative model. Why they are generative models? We'll get that in a minute. Okay. So before getting this point, understand the right hand side. Language modeling was again maths, probability, distribution. Now understand when I say probability distribution, P of, we said that there can be tokens slash words. So understand we are right now using words. The words are the mouse, egg, again the cheese. Let's say these are the words. So what probability you get considering this is x0 to this is xl, it will give you a value for 0.02. Now what is this probability? What's the basic idea behind this? Basic idea is how would human identify this? Remember they were with generative AI. If you take the input in words in a language, that's why language is model. But since it was able to generate this probability, it got there are will understand further this. This probability or this number is about how humans would identify it or how this text or this sequence, the entire sequence of the sentence, what are the chances of this appearing online as a content, as a data? That's what I'm trying to say. If you've got this like uh, example, let's move. Let's say if I write this, this is the sequence. Now this sequence, understand? Uh, Again, we're training it for the human should understand it. So when I say the mouse, the mouse ate cheese. So this is when you understand English, a lot of people do here. It is synthetic. But it means how do you write it? Synthetic knowledge. So this has we can write an algo courses. So it gets some very high chances, very likely the synthetic knowledge would be uh, again covered in the pre-training or as a language model. So the probability that you get is 0.0001. I mean, now another thing you understand synthetic can be uh, programmed algorithm or a lot of calculation maths can be put around it. But what about you see this? The understanding the cheese can never eat mouse. This is known as semantic technique. This is very less likely to happen. Uh, that's where most of the LLMs and differs basically. So yes, given these three examples, if you have got a little bit also, you might clearly understand LLM are generative. Why do we say this? Why do a lot of people just claim it? Why do we say this? Again, because of probability. The probability of words, tokens, sequence to a sentence provided, there should be definite, should, because that's how your output also would matter, can be calculated just by knowing all the letters or all the words, all the tokens. That's why it keeps generating the next token. And that's how the whole idea of LLM knows to build or generate the next token, which is also means generate the next word. Next. Yeah. Start to think on the larger scale because on a smaller platform you say IITs can go achieve in full reach. But again, uh, if it terms of humans, in terms of English, there can be a lot of probabilities because every word is being compared with the other word of its likeliness to be understood by human or appearance online. For example, in this case, when I say the likelihood of appearing the mouse ate the cheese, uh, for example, appearing online will be more because that's how human read or write or give the input. A lot of stories, a lot of places, you have this, you'll find this entire sentence. So that can be a single token. Again, I'm talking about token. We will come to that on the token. So this is all pre-training. When you put the question there, you take it in a language called English, and they're trying to better it English because again, generative questioning analogy. They also say in the latest, the worst uh, thing that has been uh, technology or release or any platform is ChatGPT. It's a worse when you compare what is happening in the IT and stuff. That I don't say GPT. It's what I'm saying is ChatGPT. I hope you can understand the difference by uh, anyways. So that's what I was saying. The likeliness of this sentence appearing online is much more than the likeliness of this sentence. The cheese ate them out. Yeah, since human don't think that way, interact with that way, read, write that way, humans generally will. Alright? You don't need to remember this. You can come back to this session again and again and prove your point here. Maths, if you understand, very good. If you don't understand, start practicing. Even if it is 2 plus 2, you'll grow. Don't worry. So now, when we talk about language modeling, there are a lot of models that can be uh, used to used for this purpose. One that is we'll be talking today is auto regressive. Regressive should ring the bell towards generative. Again, English. If you want to get better at technology, you have to get better at English. Pick up a novel. Uh, India's number one or in US number one any and start reading that. Also known as AR language model. Why we discuss this? Because currently this is what all we have, and most of them are using this. It's a very, as I said, it's very difficult to cover all the AI in this one session. So we'll be just pinpointing at some points. Obviously, auto-regressive language model is worth talking. Any questions? Please. Please put your doubts, questions, or whatever you've understood in the chat. Okay, so the question goes, how does LLM answers complex question of maths or coding? This is just the way it's done. Okay. Any other questions? I guess to answer to and get you back to where we are, what we are doing. Um, uh, we are not talking about the see that's the work of LLM. What are we doing is we are talking about this one. That will happen, or again I repeat, yes, LLM does this, but we are here. We are talking about pre-training. Okay? Your transformer, your model is built for those. Okay, that segregation happens at the LLM. Now we are here. Okay, let's get back. Auto-regressive. One of the highly used language model is auto-regressive. Now, what is auto-regressive? Since you have understood the, I hope all of you please ping in the chat. You have understood that example of probability, words, sequence, sentence. The likelihood of the first sentence is more than the third one. Please put a yes or no if you have not understood it. Okay. So now this auto-regressive, yeah, please put it in the text. Let's say x1 to xl. What it's doing is they're generating probability of every word spoken and comparing it with every other. That's how they are able to differentiate them. X2, X2 to this. Just there you'll understand it. The probability of, let's say, X1, it compares. This is also an chain rule. Probability of the other thing, which is x2 over x1. So the and mouse. So let's say this is mouse. So probability of the up and probability of mouse with the and so on. It goes on. Okay. That's very easy for them because it's a chain rule of probability. Again, maths, which is just not understanding what probability does, how you can work with it in different forms. That is also important. But just on a high level, you need all you need is a model. Is comment in the chat. This is your answer. All you need, whatever I've explained, is some model. It is auto-regressive model. Blah blah blah. All you need to understand on the high level is you need a model. You need a model that can predict next to word with respect to the past context. Context is the context is very important here. A good example would be the word bank. Now, as humans, this is what again AI cannot do, or any algorithm machine learning cannot do. When we see a river bank, we know this bank is on the river side. Or when we see a bank where we exchange a lot of things, so that's the other bank. Now, this training is actually done in LLM. Understand? We are just training, pre-training and post-training cuts. Okay? So most of you, when you go online and try to look at AI or blah 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 LLMs, they will tell you that they tell you how what's the architecture, why do you do the network, blah blah, and some algorithms. This is before it reaches their level. That's why a lot of things here is important for operations and a lot of other domains. The security domain we also fit here because they need to understand even if the because again it's a third party llama or whatever. They need to be very careful what data they're sharing and what data is that's generating. So recently you might have heard they some big company they wanted to share some public surveillance data, stuff like that to one of the authorized organizations in those countries. Being said that, just understand you need a model that can predict the next spoken word sentence. That's why we call it generative. And if you understand the context of those sentence word, again it should be human readable. So now if I think you have a good example or hands-on now understanding of what is this AR model. Now let us see how this understand again it's a language model. How this actually works. Let's say we have this model. You can call it LLM, right? Uh, I give you a sentence. Let's say the sentence is Italian likely prefers. Italian likely prefers. Now this say it's going on the internet and it's trying to search all the text or context or whatever is generated available, trying to match. Okay. So before going online, what happens is the task obviously predict, understand predict probability, next word. The generating probability of the next word, what will come after prefers? Let's say we already have the answer. We'll go this way. Pizza. Italian likely prefers pizza. Okay, and then this has to go to this model. Some probability results will be here. Okay, with some value. And that the highest one that has this. Okay, again, there's a trick in this step. Okay, we'll come to that later. So that's how they predict or they got the word pizza. There's a sort of facts and a lot of other things there. Now, once this is does, what it does is, let's say Italian is one word, one token. Likely is one word. This is another. So one, two, three. The first step is tokenize. Now you would say how this tokenization works and all that. We'll come to that. It's another. We will focus on this topic or more. Okay. Try to understand what is happening is three tokens are generated. Now once this tokenize is done, it forwards. Forwards means trying to search or generate probability. Like there can be other words. Italian likely prefers cat, dogs, horses, movies, blah blah blah. A lot of other words. The next word, okay? Right now we're just focusing on the next word. This is one process of finding the next word. Okay, and then all we all know what is in the loop. It goes on. Uh, what is the length of it, and how do we define that, or edges that? It is another topic. So when you forward this three things into this model, or let's say black box, it generates probability, scanning the internet or crawling over the internet, or how you basically it has interact data which is already interacted with a lot of other Italians. It will deep learning on the Italian side because again it will open a subset and based on the model is already trained to do this. So the number that they get is let's say high probability 0.3, but it protects pizza. That's what happens here. So you just forward it to the black box. It predicts probability of next token and samples it. Now sample becomes your fourth token. It will, see, this is one, two, three. This sample of probability, if you want a clear way, let's say, this is your kind of uh, all the words that it uh, had in sample set, it brought the probability. Okay. And now once the sample becomes the new token, then it becomes very easy to find the highest and find the highest in terms of numbers. And you can also play with it by adjusting weights. Weights again, we'll come to that topic later. And then once you have it here, you detokenize. Detokenize. Why you detokenize? I'll let you know that. You detokenize and you get the next word. That is reason. Now, one, two, three. The forward part, the black box part, and then this too. Yeah, this can be this is known as inference. Inference can be dealt with very easily, and it's very helpful also. So understanding the pre-training now becomes more important because inference on the outside on the post-training part can be easily done. We'll not go into much of the architecture where how it does this every when I say tokenize, detokenize, there are vectors, then there are key vectors, and that's how the next text or the token or the sequence or the generative uh, model keeps up. It has a downside also. If let's say if you give a fixed set, very small set, then it gets into a whole loop, and the number of tokens keeps on increasing because it has been comparing with the same. So yeah, we'll come to that issue with us. So when I was talking about the why train evidence, one of the point was architecture, second was training algorithm, data, and loss. So here, understand the another concern, loss. Loss is whether you are dreaming, hallucination, it's not following the fact, not a desired output, or how it should behave, or what was its purpose, and all that blah blah. This can depend. They figure out the loss, not going into a lot of basics, but just remember next tokens index. You classify this using cross. entropy loss. It's already there. It's math basically. They apply that concept. What I want to remember when this comes to you, or when you want to tackle this, is let's say uh, we have a sentence. I saw a cat on a mat. Again, it was trained for English, language model, English. So the model will predict. Okay, the predict will be it will take this I saw as one token, and it will have maybe it is cat, maybe it is on, maybe it is so, mat. So now these three things. Okay, let's make one for cat, one for on, and one for this is your string. It is just I saw a. Next, it is taken cat. So it will give some target here. Let's say this is one, this is zero, this is 0.1. Now they understood that this is okay, but not necessarily it can be I saw a dog when you take it on a large, or when you say it can be any word, X1 to XL. So it can be I saw a dog, I saw a TV, I saw a server, I saw a cloud, anything it can be. So what they did was they did not use this target as it is. They again a mathematical concept use log against it. Now using log, what happens is uh, it basically the subset became more small, the output became more small, and then they compared it and maximize text from. Right? So instead of this, they knew this was answer. Now they gave them this the highest weight, and then they compared with others, and then how if they find someone other word which is more probability, that's how they shift the word. So all this is based on likelihood of the word tokens and how big is your premise. Right? I think just the last thing. So generative again. So max tokens that next tokens can be generated. Uh, we can again it is goes by this formula phi of p, the probability of x one to x of I till so x of L. Uh, they know it very well. It is minimum of the log. Again, it's a mathematical formula. You don't need to go into it, but understand at the end what they focus was the min. They did the probability of all the max, so they get a very good probability in terms of min. So that's the shift I was talking about. So that's loss. Now, given that, uh, all you all the points that you should remember by now is LLM, language module, auto-regressive, uh, again, pre-training, and post-training. Model is LLM, transformer. We need to be very good with architect, then algorithm, CI plus, again, data. So you understand how important the data that you, let's try prompt engineering is also very important. Prompt engineering again plays an important role because again it is a trained model, human readable, mostly compared to online and human behavior, or the way human use those words or say those words. So very important is how do you compare everything with everything, and also individual. Probability is the game. Uh, now, before moving to tokenization, I would like to talk a lot about probability. Uh, Before that, any questions? Okay, if anybody feels this is, not my cup of tea, appreciate, not a problem. If you think this is getting too much, not a problem. Don't worry, I would say. You'll eventually understand. Because this is the latest that's happening around the world. And you are trying to learn it. Uh, with a good pace, some are with a good pace. But that's how everybody is given the opportunity. Am I audible?
Yeah, you are.
Okay. So do you all want to break? And I've asked you something. How much you've understood? Was it difficult? What is too difficult? It is like अभी तो कुछ नहीं समझा देखेंगे 10 बार या वापस हदुप पे जाते हैं. Anyone? मुख्तार भाई क्या yes क्या? Okay. No, no, no. That's why you have to stay. You remember the first day when you were introduced to any technology, you definitely did not understand. But I personally know your journey. So you almost a year, you gave almost a year. And now I think you're not scared or you were not your head is not paining or you don't think this is something magic. You will get it. Maths is a problem for all of us. So focus on maths and English. Back to school. Yeah, probability and statistics. That's it. We don't need, we never build any like, we did not build Oracle, you did not build MySQL, you did not build Hadoop. What we did was we did not build cloud. We just use their services. We master using them, understanding them. Same thing we'll be doing here. We are just getting hang of this and soon we'll be doing a lot of demos. You understand how this model behaves. We'll create our own models, very small. Then there's a lot of other thing on Google Colab and stuff like that. We'll be doing that. You understanding Gen AI from this level is very important. Transformers, very good. Everybody knows. Uh, Algorithms and blah blah. But when you get this into data operations, what kind of data, how to, you know, um, why I'm taking pre-training and post-training because every company at let's say in the next 5, 10 years would have their own team um, having their own algorithm tricks and techniques and security uh, and secrets of pre-training their data, also post-training their data. Because when at that time we are not talking about the entire ton. It would be, and they might not want the same. approach or the same, even they might go for some another architecture, another better neural architecture to the cause. That's it. I got some points on AI LLM, which I will study. Ah, यही बात है. You maybe in this 1 hour, 2 hour, not even I, nobody in the world can do this because it's a very long history. It started out from that the first Turing machine, which could say hi to a human, and a lot of algorithms, a lot of data science, a lot of machine learning, deep learning, and all this through math. I understand some people are happy because 2 plus 2 is equal to 4. That's very back of it. Machines don't have this. So this is another problem or the current problem that we are facing. But that's none of your concern. You understand this was for human. That's Generative AI. Lot of it is booming in the market. You just have to understand some points. Next time we'll discuss token. You just go through it. And that's how you answer. Your understanding will matter because the architecture is already set. The algorithm that we use is already given. You know, 12, 13 on which every data science is working. But then how to make it, how to add value to it with respect to your particular domain, to your particular client, company. Again, this is falls under a very bigger, I would say, perspective where you have to monitor every data management, resource, everything. So yeah, any other doubt? Okay, uh, it's only 12:15. We'll be back in 15 minutes. I know the lecture is going along. I'll just touch this topic called probability. Very important. Otherwise, I wouldn't have put it here. So it's not just one thing that I want you to learn because I want you to touch to a lot of things and pick up what interests or what suits you more, what you understand more. Don't worry. So stay with us. You'll figure it out. At least some of it from every. Uh, that's why we started LLM and then we touch a lot of things. Probability is important because you cannot escape maths. If you have your understanding on operation level, uh, that's very good. But then again, the position will require a much higher understanding. Maybe you are leading with the data science, or you you are actually a lead for a data science. That really matters. Or you are a part of. I don't care whether it is AI platform engineer, AI site reliability engineer, or AI cloud engineer, or uh, you are part of AI machine learning. Right? So platform will vary, no doubt they will vary, but your understanding of this will always help the client and your resume. So we'll fit because I've already talked that example, uh, the eight, the mouse, and all the cheese and stuff. We'll another 20, 30 minutes we'll talk on probability. So take a 15-minute break and I'll see you. And you can keep putting your points in the chat. That's the only way to ask your doubts. Get the full out of your money that you're paying. Huh? Eight people are there. It's okay. Then if there are two people, you can still do this. Put your points in the chat. What do you understand by again? ठीक है. Let's discuss this. है ना? एक टाइम तो होगा यार, है ना? कभी तो ऐसा टाइम होगा जब किसी को पता ही नहीं होगा कि प्रोबेबिलिटी क्या है. Am I loud and clear? want everybody to answer who's doing. होगा right time तो होगा. हाँ? So before starting with probability, let's understand कि उसके applications क्या है ना. This is this helps you understand it क्यों probability important है. उसके applications क्या है, इससे क्या हो रहा है. Then we'll get into the very maths of it. What is the maths in it? So tell me. Please comment here. Those who are, if you have commented once, if you have new idea, comment again and again. That's how I will understand how much you are getting of this. I don't want to repeat this. It simply takes a lot of time in the recording. So, many people, when they teach probability or when they want to introduce concept of probability, obviously the approach is applications. So one of the good applications are not very generally used or debated on and talked about. It's applications or implications in history. There's a very beautiful pass fail theory, and then again its implementations are which is very old when it comes to government. Again, if you're interested in finance, there's something called quant. It has huge probability, has a huge application there. If you're not interested in finance, no problem. The other thing I want to say is gambling. So most of you, if you understood what I was trying to say, I've just repeated myself. I mean, gambling. Now, some people might not like. I'm taking gambling as an example. That's up to you. I feel justified because the history of probability helps a lot of to teach a lot about history and concepts about this how this probability developed. Gambling. A lot of people had no idea. They knew there was a time when they knew, okay, ऐसा किया ना तो ऐसा होता है. That's all. To do something, do some pattern, do some recognition, or to try some this set of rules. You get this. Also, it helps to understand or explain things like points, head and tail theory. Then chess, obviously. Yes, deck of cards. What is this called in your language? Deck of cards. Yes, what is it called? Deck of cards. Are you all familiar with those card games, queens, heart of queens? So what are those deck of cards? Uh, some people call it patte in Pune. And yeah, so basically it's that. So that's why it's very important to take gambling. Lot of, and then there was time when people were working on it. There is a lot of mathematicians who was trying to understand uh, maybe how gambling works. Or there's a lot of research they have done. Again, people like Newton, Isaac Newton, was also a part of this probability. A lot of questions were put to him. But the beauty is that now, by understanding few theorems and few laws and uh, uh, some naive laws, we can think or probably uh, match the understandings of Isaac Newton. Or it's more better way of saying it. Get input from Isaac Newton to that level. Uh, this mathematics probability has taken us. So again, a very open-ended question again. What is probability by? Or what do you understand by probability? It is chances. It is chances of what? See, understand the probability. Let's take a case. Points. So there has to be something called sample space. What is sample space? It is a set of all possible outcomes. Now, when points, what are the possible outcomes? Now, said that, let me introduce event. Very important thing event is, the more better you understand it, simple definition would be it's a subset of S. It is sample space. Remember this, we come, P always stands for probability. Probability of A is favorable outcome upon all out, which means obviously this favorable outcome with respect to A. Okay. So this is P of A is everything the sample space and basically favorable events for A. Now, when we understand points, there's one more statement, a beautiful assumption here, a very impossible also. But anyways, what are the you have head, you have head tails, you have tail. So tails, head tail. Okay, so this four possibilities becomes here. Right? So that's how you calculate. So what is the possibility of this happening? So that's how we do it. 1, 2, 3, 4. So the possibility is 1 by 4. What is the possibility of this happening? 1 by 4. Again, 2 points are involved. Now there are a lot of other things we have assumed both are similar and biased points. There we can introduce or there can be some एक coin थोड़ा heavy है एक coin के ऊपर थोड़ा shine ज़्यादा है या whatever because there are 2 coins they can't be exactly same they are similar. Okay? So that's how probability works. That's all for today. We research on this, understand what is sample space, what is events, and subset. So if I draw the diagram again, this sample space and from inside it, a subset of events. Clear? Again, I got a lot of feedback on the thing was that was not clear. This is your AI box. Inside your AI, you have machine learning. Inside your machine learning, you have deep learning. Inside your deep learning, you have LLM. I think I covered most of it for today's session. Have Soil joined back?
Yeah, yes.
Okay, Soil, We're done for the session, so you can stop the recording.